Hey everybody, today's video topic is going to be on advanced filtering techniques in Pandas. If you haven't seen my introduction to data frame filtering, make sure you go ahead and watch that first. Link to that will be in the description, and you'll need to understand the concepts I go over in that video in order to understand what I'll be teaching in this video. Here is an overview of topics I've picked for advanced filtering, and I picked these not only because they are a little bit more advanced, but also because they are extremely useful. And this is the data set I'll be using. Here are 10 random sampled rows. It is a data set of English Premier League matches from Kaggle, and I did run a little bit of code here to mostly add some columns. And before we get started, please subscribe to the channel if you haven't yet already, because I'll be having a lot more of this content coming out shortly. So if you enjoy it, please subscribe to the channel. And with that being said, let's get started with the tutorial. And our first topic is going to be going over filters with multiple conditions. And there are two ways to do that, and that's with an AND statement or an OR statement, or some combination of the two. And the way we represent the AND is with the ampersand, and the OR is with this bar here. And it's very important that you use parentheses when you specify multiple conditions. Otherwise, you will get an error. And the syntax is as follows here. And you could replace this double equal sign with any logical operator here and here. And this could be an AND or an OR sign, depending on your query. So let's take a look at our first example. So let's show all Arsenal home games against Tottenham. So by reading the question here, we know that the home team must be Arsenal and the away team must be Tottenham. So those are our two conditions with an AND statement. So let's follow our syntax here and write this query. And with these multiple condition filters here, I like to create an outline. So I know I'm going to have two conditions here, and we need parentheses around both. So here's one condition. Use our ampersand for AND. And here's our second condition. So we know our layout in advance. And then we can go back in and fill in these parentheses. So this is going to be df home team is equal to Arsenal. And we need the away team to be equal to Tottenham. So we can go ahead and run this. And as always, check to make sure your output makes sense, which this does. And just to prove the point here with our parentheses and how important that is, if you forget parentheses and you just run this query as is, then you will get this error here. So very important. If you have multiple conditions, you must have parentheses here. So let's go ahead and add those back in, run our query, and now we can move on. So now let's show all games that Blackpool played in. And just logically speaking, we know that in order for Blackpool to play in the game, it must be the home team or it must be the away team. So let's go ahead and lay out our filter. So we have df, and then we have either the home team or, using our bar here as an OR statement, the away team. And we can go back and fill these in. So df home team is equal to Blackpool, or df away team is equal to Blackpool, and we can run our query. Okay, so now let's look at all Liverpool games in the 2020-21 season. And now we have to pay close attention to parentheses in our order of operations. So this is the rank order of operations for Python when it's reading your filters with multiple conditions. So it's going to run anything within parentheses first, and we'll get to that in a second. Second is going to be any AND statements, and third is going to be any OR statements. So when we're writing this filter here for our problem, we know we're going to have three conditions or statements here. One is going to be that Liverpool is the home team, or number two, Liverpool is the away team, and number three is going to be an AND. The season end year here is 2021. So let's create our layout. So we have one condition, or another, and a third. And this isn't actually the correct format to get the query that we're looking for in this question. And I'll show you why in a second, but first let's fill these in. So we have df home team equals Liverpool, or df away team equals Liverpool, and then finally the season end year is equal to 2021. So there is nothing wrong with this syntax. You're not going to get an error here. You will get an output, but you're not actually answering the question that we're looking for here. Because the way that Python is reading this filter, if we look at our order of operations, is it's going to return the and first and then the or. So the way Python reads this is either Liverpool is the home team or Liverpool is the away team and the year is 2021. So we're going to get a lot of outputs here, or rows, where Liverpool is the home team, but the year is not 2021. So let's go ahead and run this, and we'll see the problem. And right away, we have years that are 93. So to make sure this or statement occurs first in the order of operations, we need to add parentheses around it. So let's highlight this and then add parentheses. And now this is going to force Python to read this part of the filter first. So we can run this, and that is going to solve our problem. Okay, so now let's show all Chelsea wins in the 21-22 season where Chelsea either kept a clean sheet or scored at least 4 goals. So let's build out our layout here. So a Chelsea win, so that's going to be our first condition. And we need the season year here. So that will be our second. And we have a third. And our third is going to be a nested condition here. So it's going to be either a clean sheet or at least 4 goals. So within these parentheses here, we need an or statement. And we have to put these in parentheses so that this is read first by Python in our order of operations. So now let's go ahead and fill this in. So df winning team is equal to Chelsea. df season end year is equal to 2022. And now we know the winning team is Chelsea here, so we can say df a losing score must be equal to 0, so that's a clean sheet for the winning team Chelsea, or df winning score is greater than or equal to 4. And let's run that line of code. And here is our output. As always, check to make sure it checks out. So that all looks good. So let's move on to our next question. So let's find all Liverpool wins by this exact score of 4-3. So we're going to have df, and we need the winning team to be Liverpool, and the winning score needs to be 4, and the losing score needs to be exactly 3. And in this case, we don't need to wrap any of these in parentheses because these are all and statements. We have to start worrying about those extra parentheses when we're combining and or statements. And that's where you have to play around with the order of operations. But when we have all and statements here, it doesn't matter which order Python reads this in. And I'll demonstrate that in a second, but let's go ahead and fill these in. So df winning team is equal to Liverpool, and df winning score is equal to 4, and finally df losing score is equal to 3. So we can go ahead and run that. Here's our output. And just to show that these are in fact the same, if we wrap these in parentheses here, we get the same exact thing. And we can try the other subset here. So if we wrap these two in parentheses, again, the same output. So let's move on to the .isin argument. And this is essentially a way to simplify your code and make it a lot easier and clearer to be able to write multiple OR statements filtering one single column. So to demonstrate this, let's show all games that were losses by either Chelsea, Arsenal, Liverpool, Man City, or Aston Villa in week 1 of any given season. So let's start to write this the long way first, and then you'll quickly see why this isn't all that practical, I should say, and we'll want to use .isin instead. So we have df, and then so the df losing team is equal to Chelsea, and we can copy this to make this a little bit faster. Or the losing team is Arsenal, or the losing team is Liverpool, or, and we can, you get the point here, we can keep going to as many teams as we want to specify. But you can tell pretty quickly this gets pretty tedious, and you're not going to want to write, let's say, 20 or 30 of these OR statements if you want to pass through a larger list. So instead of doing all this, let's get rid of that, and we'll use isin instead. So let's create a list here of all the teams that we want to test. Copy that. Let's call this our teams list. And we'll have to make all of these strings. So now, if we follow our syntax up here, and we can create our filter. So df, and we still have the second condition here that the week is equal to 1. So let's create our outline. This part will be df week equals to 1. And now let's create our isin part here. So we have df, and these are losses, so this is going to be losing team dot isin, and the array we can pass through is the list that we are defining here. So let's go ahead and copy that, paste it in here. You can run that line of code, and let's check all of these losing teams here and make sure that they are only the ones that are showing up in that teams list and nothing more. So again, this is a much easier way of saying if the losing team is Chelsea, or it's Arsenal, or it's Liverpool, and so on. Okay, so now let's take a look at the not operator. And the not operator is this little squiggly sign that's going to be up in the top left of your keyboard. And this essentially is going to reverse the output of any Boolean series. So, for example, if a value within that Boolean series is true and you add the not operator in front of it, that will become false. Any falses will become true. And one quick note here is you must use parentheses if your Boolean series is created with any of these logical operators, as opposed to something like .isin here, which you do not necessarily need parentheses. And let's take a look at an example. So this is going to be the exact same thing we just did, but just the opposite. So all games that were lost by all teams other than these that we specified in our teams list, and then in that week 1 of the season. So we can come up here and grab this code. Let's go ahead and copy that and paste that here. And now all we need to do is say that the losing team is not in this teams list. So to flip that around, we just have to add our little squiggly line there. Go ahead and run that. And now let's check our losing team here. And you can see that none of these teams are in our teams list. And because we're not using any of these logical operators here, we're using .isin instead. This squiggly line could also go inside of the parentheses here. It doesn't actually matter. You will get the same exact output. Okay. So now let's take a look at using the squiggly line here with a logical operator. And this isn't really a practical example per se, but it's more to kind of demonstrate how this is working. So let's show all games that have produced at least 8 total goals. And another way of saying this is show all games that did not produce less than 8 goals. So the easy way to write this query is obviously just df total goals greater than or equal to 8. And this is correct, and this is the way I would recommend, but just to kind of show how this is working, let's write this same query, but using the not operator. So the opposite of greater than or equal to 8, the kind of collectively exhaustive opposite of it, is going to be less than 8 here. And then we need to wrap this in parentheses. Then in front of it, we'll just add the squiggly sign. So we can go ahead and run that. And let's check our total goals column and make sure that all of these are 8 or above, which they are. And so other examples of this would be, let's say if you wanted to find all home teams that were not equal to Everton. So say df home team, and the simple answer would just be not equal to Everton. The way to write this with the squiggly sign would be to change this to the opposite, which would be equal to, wrap this in parentheses and add the squiggly sign. I'm not going to run this line of code because it's going to output a huge data frame, but just for reference, that would be how you do it. All right, so let's move on to null values. And how can we filter columns based on whether or not values are null or not? So let's take a look at an example here. Let's show all games that ended in draws in this given season. And a couple ways to do this. You could set home goals equal to away goals. That's absolutely viable. The other way here is if we look at our winning and losing data over here, any draws, we're going to have null values for all of those columns. So let's use the .isna argument here to solve this problem. So we have df, and then we need 2 conditions. One is the draw, and the second is the season end year. So df season end year is equal to 1999. And now we want null values for, we could pick any of the 4, but let's say df winning team, and our syntax is simply .isna. Forgot our dot there. And here is our output. So you can see that all of the values here in the winning team column are null, which in the context of this data set means that we have a draw. Okay, so let's do the opposite of that now and show all games that did not end in draws in that same season. So we can copy this line of code here, and there are 2 ways to do this. One of them is you could use the squiggly sign here, and that will give you all of the games that did not end in draws. Perfectly correct and viable. But there is also an actual argument for not NA, and that is like so, not NA, and that is the opposite of isna. So both of those are perfectly viable and correct options, and it just comes down to personal preference of what you want to use. So next up are subqueries. And a subquery is essentially a query within a query. And the reason these are important in particular is because you really want to avoid hard coding. And the reason being is so that you can future-proof your code, which essentially means you're accounting for future changes in your data set. So for our example here, to kind of understand why this is so important, let's show all games that set the record for most total goals scored. So the foundation of our query here is going to be df, and then df total goals, and then we'll set that equal to some number, whatever the max is. So we have to calculate this number. We don't know that number off the top of our heads. So we can come up here, we'll create another cell, and let's calculate the maximum total goals scored. That's simply just going to be df total goals dot max. And there's our number. So it's 11. And the really important part here is rather than just putting 11 in here, that is an example of hard coding, we want to put the calculation to get that number in here. Because let's say, for example, we're constantly updating this data set, and highly unlikely, but what if there's a game tomorrow, and in that game, there are 12 total goals scored? If that's the case, we get our new data set, and you have hard-coded 11 in here, and we rerun this this code, then our answer is going to be wrong. So we want to input the calculation rather than the hard-coded number. So we can copy that and paste that in there instead of the hard-coded number. Another option, and this is probably a better practice, is to, rather than putting in this whole calculation, you could create a variable here. Like you could say, let's call this max goals. We can run that and set our total goals equal to max goals. And there's our record. So 11 total goals in a game of Portsmouth versus Reading back in, what is that, 07. Okay, so second simple example here with a subquery. Let's show all Liverpool home games where Liverpool scored more goals than its home game average. So as always, I think it's a good idea to build out that query first with your filters, so df, and then we have two conditions here. So one is that the home team is Liverpool, so we have that part here, and that the number of home goals scored for home team Liverpool is going to be greater than or equal to some number. So we have df home team equal to Liverpool, and df home goals greater than some number, which we now need to go and calculate. So let's do that. And in this case, we need to filter not only on the rows, so where the home team is Liverpool, but also we want to return only one column. So we want to return that home goals column. So let's go ahead and do that. So we need to use df.loc. And our rows condition is going to be that the home team is equal to Liverpool, and then we want to return the number of goals scored in each of those games by Liverpool. So this is going to give us just a series. So we can add on the end here just a dot mean, and that'll give us our number. And let's go ahead and set this equal to a variable. We'll call this, we'll call this Liverpool average home goals. Copy that, make sure we run that line of code, and then we can put our variable right in there. So I think this number was a little bit over 2, so that would mean in order to meet this criteria, we'd have to have a Liverpool home game where they scored at least 3. So let's scroll down this home goals column, make sure all these numbers are 3 or above, and it looks like they are. So we can go ahead and move on. Okay, so the dot between argument here, pretty similar to .isin, where there is a long form to do this, but dot between is going to make this a little bit simpler. And dot between is basically a shorthand version of saying that a value in the column is greater than or equal to one bound on the left, and it's less than or equal to the bound on the right. So this will just make this a little easier and clean up your code. So let's take a look at an example here. Show all games played from weeks 15 to 20 in the 2000-2001 season. And we have our syntax here. So we have df, and then two conditions. One is going to be the weeks, and the second is going to be the year. So we have df season end year, and that equals 2001. And now let's add in our dot between. So we have df week dot between, and then our bound on the left that we want it to be greater than or equal to is 15, and our upper bound here is 20. And let's take a look at our columns here on the left. So season end year should be 01, and these should all go from 15 up to 20. Perfect. All right, so next and last here, it's going to be a little overview of substring queries. And I recommend, I actually have a full tutorial on substring queries. So if you haven't seen that, that'll go into a lot more detail than I'm going to go into here. But a substring is pretty much a string within a string. So for example, here, we have Manchester United and Manchester City. And a substring of both of those is going to be Manchester. So Manchester appears within both of those strings. And here is our syntax for querying substrings. And let's show all home games for either of those Manchester teams. Forgot S there. Between these seasons. So we're going to have two parts of our filter. So we have df. This will be the substring query, and we have the season. So we can use dot between for this. So this will be df season end year dot between, and then we want it to go from 2018 to 2021. And now let's write our dot string dot contains. So df, and we want the home team dot str for string, and then dot contains, so basically the string within the string. And then we need to specify our substring here, which is going to be Manchester. Also, we could say something like Manchess or Manch, because I don't think there are any other teams that have that exact string. So just to kind of emphasize the point, it really shouldn't matter in this case. We can write Manchest. And let's go ahead and run that. And so we have all of our season end years, and all of these home teams are one of the Manchester teams. Just another quick point here, if we want this to be case insensitive, if that's something we're concerned about, you can set case equal to false. So that's false is case insensitive, the default is true. And if we set that equal to false, we could change this to a lowercase m, for example, and this is still going to run. But I have a lot more detail on .str.contains as well as a bunch of other arguments in my substring tutorial video, so definitely go ahead and watch that if you haven't yet. But that is the end of the tutorial for today on more advanced data frame filtering techniques. So please leave a like if you enjoyed, and subscribe to the channel for a lot more of this content going forward. And as always, thanks for watching.